Tonight, somewhere near you, a person you've never met is going to drop a lit flame into a steel tube, and a few seconds later, you'll tilt your head back and say, "Ooh." You won't think twice about it, but the thing blooming over your head, that perfect silent flower of light hanging in the dark before the sound even reaches you, is a thousand-year-old accident. It was invented by people who were trying to live forever. They failed, and the failure was so beautiful that we've been launching it into the sky ever since. For more than 1,000 years, every culture that has ever seen this has stopped talking, looked up, and felt the same small thing in their chest. So, how does a paper tube of powder become a chrysanthemum the size of a city block? The answer runs through a Chinese alchemist's furnace, the inside of a single atom in a piece of cardboard cut by hand. And once you see it, you'll never look at the 4th of July the same way again. It starts with a search for immortality. Sometime during China's Tang Dynasty, between the years 618 and 907, alchemists were mixing chemicals trying to brew an elixir of life, a potion that would let an emperor live forever. One of the recipes they tried combined three ordinary substances: saltpeter, which is potassium nitrate, plus sulfur and charcoal. It did not grant eternal life. It exploded. They had accidentally invented gunpowder, and a Chinese text from that era literally warns alchemists not to mix these ingredients because some who did had their hands and faces burned and even burned down the building they were working in. The elixir of immortality turned out to be the most destructive substance humanity had ever touched. But here's what's fascinating: the Chinese didn't even need gunpowder to invent the firework. Long before, during the Han Dynasty, people were already throwing bamboo stalks into their fires. The hollow chambers inside the bamboo would heat up, the air and sap trapped inside would expand, and the stalk would burst with a sharp crack. They called these exploding bamboo, and they set them off to scare away evil spirits at the new year. That's the secret hidden inside the word. The very first firecracker wasn't a chemical at all, it was a plant. When the new exploding powder came along, someone simply packed it into those same bamboo tubes, and the bang got a whole lot louder. By the Song Dynasty, that powder had been rolled into tubes of paper with a tissue fuse, and the modern firework was born. But to understand what's actually happening over your head tonight, you need to open one up. A modern aerial shell has four parts. At the bottom is the lift charge, black powder that ignites in the tube and throws the whole shell upward at over 100 meters per second, faster than a sprinting cheetah in the blink of an eye. As it launches, that same flash lights a time delay fuse, a slow burning thread calibrated to a fraction of a second. The shell climbs, the fuse burns down, and at the exact top of its arc, the moment it goes weightless, the fuse reaches the burst charge at the shell's core. That charge explodes outward, and it ignites and scatters the real payload, the stars. It's where the chemistry begins, because the stars are where the magic lives, and the color they make is not what you think it is. Watch a firework, and your brain tells you it's colored fire. It isn't. The color has almost nothing to do with the flame. It's coming from inside the atoms themselves. There are two completely different ways to make light in the sky, and pyrotechnicians use both. The first is incandescence. Heat something until it glows. That's how you get the gold and white sparks. Metal burning so hot it radiates orange, then yellow, then white, the same way a stove element does. But incandescence can only ever make you those warm colors. To get a true red, a green, a blue, you need the second, stranger method, and it's pure quantum physics. It's called luminescence, and here's what's actually happening. When you heat a specific metal salt, the heat kicks its electrons up to a higher energy level. They don't want to be there. So they fall back down, and as each electron drops, it spits out the exact amount of energy it absorbed in the form of a single particle of light. And the size of that drop determines the color. Strontium throws out red, barium throws out green, sodium throws out yellow. You are not watching things burn. You are watching trillions of electrons fall, each one releasing a precisely tuned flash of color all at once. The late John Conkling, the chemist who literally wrote the textbook on this, Chemistry of Pyrotechnics, and trained pyrotechnicians for nearly 30 years, spent his life turning that quantum staircase into a craft. And this is where it gets almost cruel. There is one color that has tormented firework makers for centuries: blue. The only practical way to make a true blue is with a copper compound, copper chloride. But copper chloride is fragile. If the star burns even slightly too hot, the compound falls apart before it can make its color, and your blue collapses into a washed out, dirty white. Red is forgiving. Strontium burns reliably between 1500 and 1800 degrees and shrugs off mistakes. Blue lives in a razor thin window, hot enough to glow, but never hot enough to destroy itself. Pyrotechnicians call a perfect deep blue the holy grail of their craft, and it's the truest test of a master. So the next time you see a rich, saturated blue burst overhead, understand what you're really looking at. Someone threaded a needle, they balanced a chemical reaction on a knife's edge 300 feet in the air in a tenth of a second, but a color is only half of it because someone also decided the shape and they drew it by hand. We imagine that a fireworks burst is random, the chaos of an explosion. It's the opposite. That spherical chrysanthemum, that ring, that heart, that smiley face, every one of those is designed. Inside the shell, the stars aren't dumped in loose. They're carefully arranged, often glued one by one onto a curved cardboard frame in the exact pattern you'll see in the sky. Pack the stars evenly around a sphere, and the burst opens as a perfect globe. Glue them into the shape of a heart, and a heart is what blooms. The explosion doesn't make the shape. The explosion just inflates a picture that a human being laid out by hand hours earlier on a workbench. Which leads to one beautifully human problem. A shell tumbles as it flies, so the maker has no control over which way the pattern will be facing when it bursts. Aim a smiley face the wrong way, and the crowd sees nothing but a flat line of dots. So, how do they fix it? They cheat with numbers. They fire several identical shells at once, trusting that at least one will happen to be turned toward you. That ring you saw, there were probably three or four of them launched together, and you only caught the one that was aimed at your eyes. These pattern shells are surprisingly recent. They first lit up American skies in the early 1990s over Washington to welcome troops home from the Gulf War. And we have never stopped chasing bigger. The largest firework ever launched went up over Steamboat Springs, Colorado. In February of 2020, a single shell 62 inches across, weighing 2,700 pounds, wrapped in 51 miles of paper tape. It needed a mortar buried 26 feet into the ground, and it climbed 2,200 feet before it bloomed. From a stalk of bamboo cracking in a Han Dynasty fire to that. And here in America, the connection was deliberate from the very first night. On July 3rd, 1776, John Adams wrote to his wife Abigail that independence should forever be celebrated with pomp and parade, bonfires and illuminations, and in the language of his day, illuminations meant fireworks. 1 year later, on July 4th, 1777, Philadelphia did exactly that. A show that opened and closed with 13 rockets, one for each of the 13 colonies. So, what if the thing we line up to watch every summer isn't really about the explosion at all? What if it's a message in a bottle from people who are long gone? Think about it. The alchemists who wanted to live forever never found their elixir, but their accident is still rising into the dark every single year in every country on earth. The monk who packed powder into bamboo to frighten away spirits, the chemist balancing copper on the edge of destruction just to give you 10 tenths of a second of perfect blue, the hand that glued 100 tiny stars into the shape of a heart. You tilt your head back and you say, wow, and you have no idea how many ghosts are in that flower of light. They were chasing forever, and in a way they never expected, looking up at a 1,000-year-old accident blooming silently over our heads. That's exactly what they got.